So for the first question, we need to find x1 omega, which is rec omega over W. First, we draw the graph, and for this question, we have multiple methods. The first one is more complicated but more straightforward. We do it by the hardcore integral. We can see this is just all rudimentary integrals, but here we use a identity here, which is sine t equals to e to jt over 2j minus e to the minus jt over 2j. So we transform the result to this, which will give us this. And we have the final answer, which is w over 2 pi times sinc to wt over 2. For the second method, we apply two identities or properties. By applying these properties, we can make a little chart here. We're starting from the two given signals in the property and step by step transfer it into the signals we want. As we can notice, the A in the identity is 1 over 2 in this question. And we can have the final result, which is underlined. For question 2, we need to find the signal whose Fourier transform is x2 omega, which is given by this graph. So we do this by a hardcore integral. Here we use integration by part. And we have this. Here we use another identity, which is cosine t equals to e to the jt over 2 plus e to the minus jt over 2. Using this identity, we can transform the result into 1 over pi t squared times 1 minus cosine wt. Here we need to use another identity, so we can find this. And by multiplying the denominator and denominator by w squared over 4, we can have the final result, which is underlined. For question 3, we need to find the signal whose Fourier transform is given by this graph. This question we also had two methods. The first one is a hardcore integral. Oh boy. So we expand the integral into two parts. We integrate from -5 to -3 and 3 to 5. We can skip through all these steps, but here we need to use a identity that we used before to transfer the result into this. And we turn this into sinc or sinc, and we have the final result. The other method will be much easier since we're using the result from the first question. By observing the graph in the question, we can tell that the signal equals to a rect omega over 10 minus a rect omega over 6. By applying the results on question 1, we can simply transfer the question into the final answer. The end.